Alright guys, we had a little bit of a camera malfunction, so we're going to swap over to this other camera and I'm going to go ahead and unbox this inverter for you. So if you listen to the podcast, you'd know that the reason why I chose this inverter was not because it was the cheapest, most cost-effective, and most feature-laden inverter out there. It can do what we need it to do, and I've got experience with it. I've used it before, and I trust it, and that's important. So here we go. This box out of the way here. All right, so there we go. There's the inverter. 48 volts in, 3,500 watts out. I'll get into the specs here in a little bit to talk about what kind of solar input we can utilize and how the different charging functions work. But it's just a good, like I said, relatively cheap inverter that will do the job that we need it to do. And my entire house has actually been running off of this generator for about 2 months. We had a short in one of our old, we had a short in one of the old dual inverters, so we sent both of those back to get replacements, and we have the replacements. And then now it sounds like we're going to get replacements for those replacements, but I don't want to get off on a tangent. This is what we're going to be using. So this is going to be the guts of the whole system: AC in, AC out, DC in from the battery, DC in from solar panels. It works great. There's no issues or problems. And so yeah, we'll get into this. Let's see, 3,500 watts. Let's see here, 40 amps is the maximum bypass or charge current. So if we've got AC in, then we can actually go up to 4,800 watts out instead of the 3,500 that it's rated when it's just on battery power. And PV input, so this is something important. So we always want to make sure we understand what the input voltage range is. And so for this inverter, it's 60 to 115 volts DC. The maximum open voltage, so that's no load open voltage on this, is 145 volts. So when we're looking at how we're going to put our solar panels together to power this, those are the numbers that we need, along with 50 amps. So you can actually take some pretty substantial amperage on the input. Now, we are going to be limited by this cable here. So this will be the weakest link in the whole system, the thickness of this cable. This cable will not take 50 amps. So what we're going to do is we're going to just look at whichever panels that we decide to pair with this unit and make sure that whatever we put in does not overload the actual amperage maximum of this wire, because this is our weakest link. But the inverter itself will go up to 50 amps, so you could step that up and get some beefier cables if you wanted to. Let's see, 4,400 watts is the maximum input on the PV side. And then our maximum charge current on the DC side. So we said we had 40 amps on the AC side. On the DC side, it's 80 amps. So essentially, if we were to max out the voltage, we could go up to about 4,200 watts of actual solar power coming in and going into the battery. We don't want to charge this battery at 4,000 watts. So that's kind of like the art when you're talking about a solar system, is making all the components fit together so that you're not maxing one thing out and damaging something else in the process. Phillips head, I'm going to go ahead and take the base plate off of here, the bottom section. That's going to allow me to get in here and to actually make all of my connections. There you go, that's simple, 2 screws. So if we look in here, hopefully you can see it in the video, we've got our AC in, so it's ground, line, and neutral, so there's your hot. And then you got your AC out, which is just line and neutral. Over here we've got our PV inputs, and then these 2 bigger ones in the back are our actual battery inputs. So our battery cables will come in through here, they'll connect right there in the back. Our PV cable, or actually our extension cable, will come in right here, and then our AC in and our AC out. We handled right there. And what we'll do is we'll just tie all of our grounds together here. Now, this system won't actually be grounded. It's not going to be like attached to a ground rod, but it's got internal ground fault protection. So what happens is once we tie all of our grounds together, in the event that we have some sort of objectionable voltage somewhere, it'll just trip the system off and say that it's got a ground fault. And then what I'm going to do is I'm going to take one of those little boxes, probably the one that the Bluetooth dongle came in, and I'm going to just put all my screws and stuff in there because I have a bad habit of losing my screws when I'm doing a project like this. Go ahead and get the coffee over here. Drinking some hollow roast coffee out of my homemade Hack My Homestead coffee cup. I say homemade because I didn't make the actual coffee cup, I just put one of my stickers on it. So yeah, we'll just use the Bluetooth. Oh, and I don't think I showed before when I opened it up, but this unit actually comes with a remote control as well. So all you can do with the remote control is turn the unit off and on, but it's nice to have an on-off switch on the outside so you don't have to open it up. So that's what that is. So we'll mount that on the outside of the box. There's the cable that runs in between this little remote input right here. We'll go to this, and then when you're operating the system, your on-off switch, you've got on, off, or remote. So you can just be on, you can just be off, or you can put it on remote, where this little push button turns the inverter on or off. So before I have my stuff blown away, I'm putting those two screws in there. I'm going to go ahead and put all my mounting screws for the different components in here. And I've got my terminal screws, my lugs, and my battery screws. Let's see, do I have any other screws? And what I've done is I've taken all of my paperwork and I just put it all in this one little bag here, and that'll go inside the box. I think I mentioned before, but I'm not sure I showed myself actually opening it. But I've got this controller here, and so what'll happen is this is our thermometer. Okay, there's our probe, and so this will plug in here. Then we'll have a on-off switch, not an on-off switch. We'll have a power switch, and then what this will do is this will turn the fan on or off depending on the temperature settings. And then we've just got our plus, minus, and OK so that we can actually set the on and off. And now this controller will actually go for a 12 volt all the way up to a 48 volt fan. So you can use the same controller. The controller I think was only $9. I think the fan was like $20. When I edit the video, I actually put the prices of everything in here. But just to run through again, all of the components, we have the battery, 48 volts, 50 amp hours. We have the inverter charger. We have our temperature controller for our fan with our temperature probe and our actual brushless 48 volt DC fan. Okay, that'll be mounted on the outside of the box. We have our XT60 plug that'll go from the inverter to the exterior of the box, and then this will be our cord where we go XT60 to solar panels. So this is DC power in components, and then this is AC power in component. So I'll run this to the AC in, cut the end off, and then this will be mounted on the outside of the box. And again, it's weatherproof, so that if you want to run run it as a UPS or charge it from just plugging it in, that's what you'll do with that. And then our AC out is very simple. We just have these two boxes. So this will be on the side, this will be on the front. The front one will have an on-off switch, and both of them have USB-C and USB-A outputs. Oh, and then finally, we've got the Bluetooth dongle so that you can actually use the Bluetooth app to manage this as well. Not a ton of actual utility in that, but it's something that's a big marketing ploy for the EcoFlow systems, and so I wanted to build something that was similar. So all of these components that I just showed you, everything here on the table that's going into the build is about $1,260 $60, something like that. And then I didn't have to go buy connectors and wiring because I do enough of this stuff where I've got it. But realistically, you're looking at about another $30 in wiring components. And so for well under $1,300, you're building something that's going to compete with a $2,600 system. All right, guys, I have some battery cables here that I already had. These terminal ends looked really good. There's a couple spots where the exterior of the insulation was just barely nicked, so I just gave it a few wraps of electrical tape. It was not down to the actual wire. The wire is fully intact. It's just small nicks, and really it was just on the positive wire, so I just gave it a few wraps. But I cut the old terminal ends off, and so what I'm going to do now is I'm going to take these terminal ends that came with the Renogy inverter, and I'll crimp those on the ends, and then I've got shrink wrap that will go on as well. So handy dandy terminal end, hydraulic crimping tool. Those guys in here like so. And what I normally do is I get it down where it's just grabbing it, and then I kind of position it the way I want it. Because you want the crimp in the right spot. You want the wire fully seated. Normally I would be doing this on a bench, not on the bed of a truck, but I've got to do it in a place where I can actually show you guys what's happening here. Right, almost. Where I want it, then I'll push the wire end. That's out just a little. Okay, I believe that's where I want it. Wire is fully seated, so let's get the clamp out. All right. And of course, as sometimes happens, the clamp actually, so I always give it a good solid pull just to see if I can get it out. Let's see here. Yeah, we're gonna, this happens sometimes with these crimps. So there we go, we're in there good, we're not coming out. But now the actual transition from the wire to the terminal is giving me some fits with my shrink wrap, but that's okay. I just slowly work it on there. Just a little more. Almost. There we go. So the face of the terminal is the only place where there's actually going to be a transfer of electricity. So I want my shrink wrap to pretty much cover the crimp, the wire, the whole 9 yards. So pretty much like that. That's how I want it to look. And then I've got my other cable. Keep a knife in my pocket. I'll go ahead and give this guy a little bit of a strip. For smaller wire, I typically use an actual wire stripper. For larger wire, I like to use my knife because I've got a little bit more control over it. And I just think it gives me a better end product, especially when I'm working with this really thin, it's almost like welding cable, in that, there we go, no, not quite. It's got a bunch of really thin strands, so I don't want to cut a bunch of strands. I just want to cut the insulation. So using my razor knife gives me a little bit more control in that regard. So let's see what I've got here. Okay, yep, that'll work nicely. I'm gonna go grab a piece of red shrink wrap. So I just like buying these multi-packs where you get a bunch of different ones, and typically your, I think it's 3/4 or 5/8 of an inch is the right size for 6 gauge wire, or 8 gauge, wait, 4 gauge. Oh, that is definitely not the right size. I believe it's going to be one of these two. Well, they're the same size, so how about that? All right, so I'm going to go on with this first, and then I'll close this bad boy up, because obviously I'm going to end up with stuff everywhere if I don't. So that's probably a lifetime supply of shrink wrap in that little case right there for most people. Alright, so on with my terminal, and I'm going to do the same thing. See if I can do this one from the side. You guys might actually be able to see what I'm doing here. So I'm going to put the terminal in like so. I'm sure you can't see through my fingers. Exactly, there we go. Okay, I don't want to start crushing it yet. So now I'm just going to take my wire, fully seat the wire, and I can actually see it on the other side. And now I can go ahead and start crimping this thing. And you just crank it until it stops. You'll actually, probably can't hear it in the video, but you actually hear the psh when the pressure is kicking it out the side. So there we go. And then shrink wrap on. So I'll go get a torch real quick where I can shrink wrap this, or shrink this, and then we'll be ready to put it on the battery. All right, couldn't find my torch. And I really don't want to use my heat gun because I live off-grid. So we're just going to use the old lighter, tried and true lighter method. Cables are done, so I'm going to go ahead and take my input here, and I'm going to cut the end off. I like leaving a little bit on the end, that way I can, you know, use it for something else potentially in the future. That's how us hoarders justify keeping everything, is, well, you know, you might need it in the future. Might need to go down a little bit more on stripping this. And again, I'm using my knife. I'm using I'm cutting it and then I'm kind of bending it so that the insulation breaks, because I don't want to get down into the lower. And so real simple, we've got hot, we've got neutral, and we've got ground. Those are our three inputs on the other side. So if this was to be plugged into a household circuit and the house was obviously grounded, then that would actually provide the ground for the whole system. But in the event that it's not hooked up, the grounds for the output will also be connected to the same side, and the inverter has a built-in ground fault interrupter. So because we're going to be tying these into the ground side as well, we won't have any problems, or we will have less problems. All right guys, we're going to go ahead and hook up our battery cables to the inverter. So this is not the easiest process, the way they have these things set up. I'll probably drop this a few times, but they've got this nice protective shield here, which is great, but doesn't make it super easy to get to the actual terminals, and they're not exactly magnetic, so that makes it a little bit tougher. So I'm going to do the best I can to make it to where you guys can watch this whole process, so you can do the whole thing yourself, but some of this stuff you're just going to have to like assume once you get your own system opened up. There we go. So here what I'm doing is I'm actually throwing it down through the battery terminal, and then the cable in terminal, and then I'm using that to actually use it to put it where I want it. So there we go. And I'll come back with a torque wrench before we finalize and actually torque those down, but that's what it's like. Positive, negative, real simple. It's the only connection that we've got made so far. All right guys, so here's where we are right now. I've got the battery in here. Show you. There's my battery terminals. So the battery's in. Got my positive and my negative the way I want them set up. And what I went ahead and did is I used the shipping stuff that they put in there to protect, and I just kind of kept that in there because, you know, imagine this is in the back of a truck or something going down the road. You do want a little bit of protection here. So then I cut 3 pieces of 2x4 down just so they'll fit. And so this is a tapered channel. It's smaller at the bottom than it is at the top, but I cut it to where they would fit almost perfectly right above the battery. And I will actually screw those in from the outside here. And once those are screwed in, then I'll put my inverter on top of that. And I may actually come in through here with my hole saw and just knock some holes in it, just to make sure that we've got good airflow underneath the unit. But that does a couple things. It gives me something solid to actually mount the inverter to, as well as gets the inverter closer to the top so that I can access you know, all of the different connections, and I can access the control screen as well. So what I'm thinking we're going to do is we're going to put our inputs here. So we'll have our AC and our solar input right there in between these 2 channels, because that's going to be a pretty strong area, and now it's protected. So if something wants to slam up against the side of this box, it'll hit these channels and it won't hit our actual pieces that we're going to have for the input. So I think we'll put the AC one up here and then the solar one just below it, you know, probably right solar here and AC somewhere in that area. So I'm going to go ahead and get started on getting those holes in and getting that in, and once that's done, I'll be able to go ahead and put the inverter in there. I'll slide the battery back forward. Right now I'm just using it to keep all these at the same elevation. I'll slide that forward, and then I've got a smaller piece here that I've actually marked lower, and I'll put that down here, and then I'll put a little piece of plywood. And so this will be a storage area where I can store extension cords, I can store PV cables and such, and that'll be where all my, so basically this side will be my operating side. I'll have all of my inputs here, here, and here. And then on this side, I'll have this open area for storage. And so as you can see, we've got a significant amount of room in this thing. And you know, as I'm putting it together, I'm thinking we could probably build this in one of those smaller units. So the next build I do, I might actually take this battery out, use the bigger battery in this build, the bigger, heavier battery, and then use the smaller battery in the smaller case. So we'll see how it turns out, but I'm gonna get to cutting holes and moving forward with getting this thing finished up. I didn't show you, but I'll show you when I do the PV cable, or rather the, actually I can show you on the PV cable, but I went ahead and put collets on this plug. It just helps hold everything in place and make it less likely that the screws will kind of vibrate out or that the connections will come loose. Now, with this system, if you're putting it in the back of a truck and driving it around, you want to regularly get in there and check it out. But I'm gonna put all the safety mechanisms in place that I can, some strain relief and stuff like that. So let's see here. We're gonna use a 2-inch hole saw for this next one. Right above. If I was super worried about this being beautiful, and that, of course, that's going to get covered up, but if I was super worried about that, I could actually put the drill in reverse. It would cut slower, but it would still cut through this plastic in reverse. All right, so what I'm going to do now, I've got these ends for our PV input, and I'm going to put 2 10-gauge collets on it. So slide it right over. I went ahead and cut the tinned end off and re-strip these to get myself the right amount of room to work with. There we go, down and down. And then I just have this nice little tool here. Push that all the way down to the insulation. occasionally I'll cut it. This one worked out pretty good, but occasionally I'll cut it and I'll still have some wire sticking out the end, so I'll just go take my cutters and cut the ends of it off. But that's what that looks like, and that makes it really nice and makes sure that I've got full contact, and makes those connections a lot stronger when you do that versus smashing down the stranded wire. All right, so we're going to go ahead and secure our AC input, and I've gone ahead and marked the spot that I'm going to put our AC output on this side. I'll do the same thing on the other side, and then I'll cut those out. I think what I'll do is I'll just drill the corners and then use my Sawzall with a metal blade to get a nice clean cut there on both sides so that we can put these in. And I'm looking at it, there's not really a good seal on this, so what I'll probably do is just put a little bit of silicone around that when I secure it, and then hit the back side with a little bit of silicone as well, and kind of waterproof that one opening. Everything else has a rubber gasket around it, but these don't, so just a little bit of extra protection there I think would be a good idea.